Hey guys, and welcome back to Mathematics, where we put the fun into fundamental theorems of calculus. That's right, I just said that. Not really sure why I said wait. This is me sitting in a dark room by myself talking to a computer. But anyway, today we're just going to look at some revision questions from your further integration topic, because we'll be moving on pretty soon. So this might be a two-parter, so this one isn't as long as the last one. Okay, let's get stuck in. All right, for our first example, we're looking at from the 2019, this is from the advanced HSC exam, but now this would be considered extension 1 content. So we have the region bound by the curve y equals x minus x cubed, shown here, between the x-axis and 0 and 1 is rotated around the x-axis to form a solid. Find the exact volume of the solid formed. Okay, so when we're approaching a question like this, hopefully the first question you're asking yourself is WTF, which of course stands for what's the formula? That is the correct question. Here is the correct answer. Here is our volume around x-axis rotation formula. Okay, we have the integral between a and b of the function squared and then multiplied by pi. So we looked at in class how this kind of generates a disk and then it sums together all the disks to make a solid, which is very convenient. So all we need to do to answer this question is first of all get our function squared. So right now we have y. We need to find y squared, and we just need to integrate that between 0 and 1 and then multiply by pi and find the exact answer, okay, for 3 marks. So let's have a look. If you want to attempt this by yourself first, of course, pause the video, see how you go. But if you've already done that, we can just get stuck in. So here we go. First of all, like I said, here is y. We don't need that. We need y squared. Okay, and be careful with this because potentially a common incorrect answer could be just squaring both of these terms and doing x squared minus x to the 6. But keep in mind, you've got to put a bracket around this and do a perfect square expansion. Okay, so we're going to end up with x squared, and then we're going to multiply the two terms together to get x to the 4, and then we're going to double that to make 2, and we've got a minus there. Okay, so minus 2x to the 4, and then the last term squared is x to the 6. Okay, so if you forget this, you're going to miss this term in the middle, and your answer is going to be whole kinds of wrong. Okay, so now that is our function squared. Now all we need to do is integrate this guy from, like I said, 0 to 1, the two limits where we're rotating around. Okay, this is a pretty straightforward integration. There's nothing too scary going on here. We just got to use our basic indice power rules, I suppose. So we're going to get x squared is going to turn into x to the 3 over 3. We're going to get x to the 4 over 5 multiplied by minus 2, and we've got x to the 7 divided by 7. Okay, don't forget your pi out the front, because that's going to get you a wrong answer if you leave that off. We need to sub in 1 and 0, which is pretty convenient, because subbing in 1 is very easy, and subbing in 0 gets 0 minus 0 plus 0. So we really only need to substitute in 1. Okay, so I'm going to go up here now, and we're going to substitute in. So we have pi times our 3 answers with 1 substituted in, and like I said, we're just also doing minus 0, which is nothing, so you can almost just leave it off. We're going to tidy up what's inside there with our calculator, and it's going to tell us that it's 8 over 105. Okay, so we need to write 8 over 105 pi units cubed. Okay, now that is your exact answer, and it's important that you leave your answer like that because the question said find the exact volume. If you put this through your calculator with the pi, and you got a decimal, you could potentially be losing a mark here because you haven't answered the question in the way it's specified. Okay, so as with any question, make sure you are reading it to double check that your form of an answer matches what they're asking for. And of course, it's always good manners to write units cubed, but if you forget that, I can't really see you losing marks, but it's a good habit to get into. Okay, there's the first one, so that's on the volumes. Remember that we also did volumes around the y-axis, so make sure you practice some of those. But for the next one, we're going to look at an integration involving sine squared or cosine squared. In this case, we're going to do sine squared. Okay, so again, this is a question from the 2019 exam. This is from the extension 1 paper. And okay, so the key to doing this question is just recognizing that you need to find the right sub. Massive shout out to Subway right away for sponsoring today's video. Eat fresh. Okay, so the thing you need to know to answer this question is that sine squared x is equal to a half of 1 minus cos 2x. Okay, we derived that substitution in class, but if you forget it, like I said, it is on the formula sheet in case you've forgotten. Okay, so there's really no excuse. All you need to know is that for a question like this, where you have a sine squared or a cosine squared, there is a substitution either in your brain or on your reference sheet. Okay, so if this is sine squared of x, if we just change that angle to 4x, we just need to multiply the 2x on the other side. Okay, so we have x being multiplied by 4, so we get 2x multiplied by 4. Okay, there's your substitution for sine squared 4x. Now we can make that even easier by multiplying both sides by 2. So we get 2 sine squared 4x, and on the other side we're going to have the half multiplied by 2, which just makes 1. Okay, so this question is actually kind of well designed because the substitution for 2 sine squared 4x is actually quite simple. So instead of integrating this, we'll just integrate this, which is much less stress. Okay, so we're going to change the question to integral of 1 minus cos 8x dx, and now that's just a pretty basic advanced question. Okay, so we'll integrate that. 1's going to integrate to x, cos x integrates to sine x, but you need to divide by 8 because you're doing essentially the reverse chain rule there, and we still keep the negative. Okay, and if you've gotten to this point and you've forgotten the plus c, shame on you. You should know better than that. Okay, so there is your final answer. So what you can see is if you know how to find the right substitution, these questions are often really, really simple. Okay, so you need to know your substitutions and you need to be aware of them. All right, that's it for part 1 for today. I will upload part 2 to these revision questions tomorrow. Thank you for watching part 1. I'll see you later.